Hello, everyone, and welcome to Caltech Energy 10. My name is Neil Fromer with the Resnick Sustainability Institute at Caltech, and I will serve as the moderator for today and tomorrow's presentations. The Resnick Institute is one of the sponsors for today's event and serves as a focal point for energy and sustainability research at Caltech. Thank you all for joining us for today's public program, a day and a half of presentations and talks to help us all understand how we can cut US emissions of global warming gases by 50% in the next 10 years. We'll hear more about this in the introductory comments. So I'll simply say that if the US can accomplish this goal of a 50% reduction in 10 years, we will demonstrate to the world that meaningful action to address climate change is possible. Without this transformation, climate change will radically alter the human experience on our planet in painful and painfully uneven ways. Today, we can learn from experts, gather information, data, and inspiration on how we might reach this aggressive but essential goal. The development of CE10 was a collaborative effort led by Harry Atwater from Caltech, Bert Hesseling from Stanford, and David Welch, founder of For Good Ventures, with additional support and sponsorship from Caltech's Division of Engineering and Applied Science and the Resnick Sustainability Institute. Before we get started, just a reminder to please use the Q&A feature to ask questions of the speakers during their presentations. I will come online and ask as many questions as possible given the time, and we'll end each session promptly to try and keep us on time for the day. For the same reason, I'll also be keeping my introductions of the speakers brief, but you can find full bios of everyone that speaks available on the CE10 website. With that, it's my pleasure to introduce Thomas Rosenbaum, Professor of Physics and President of the California Institute of Technology, to welcome us. Tom?
It's a great pleasure to welcome you to our campus, at least virtually. Thank you for joining us. It's easy to become discouraged reading the headlines of the day. Global warming appears to be an inexorable process, with droughts, wildfires, hurricanes, and extinctions increasing in regularity and severity. The Caltech Energy 10 conference, CE10, is a call to action and a statement of optimism. It is predicated on the belief that bringing together scientists and technologists from across the disciplines, tightly coupled to the insights provided by policy leaders and planners, will lead to the fundamental understanding, the interventions, and the will to achieve a 50% decarbonization by 2030. There are a number of examples coming from Caltech that just such an approach can change the world, from solving LA's smog problem to detecting gravitational waves. But it takes flexibility of thought, persistence, and urgency. In the case of climate change, the time could not be more compressed, and the stakes could not be higher for us, for our children, and for our grandchildren. E.B. White, the New Yorker pundit and author of Charlotte's Web and Stuart Little, opined, "If the world were merely seductive, that would be easy. If it were merely challenging, that would be no problem. But I arise in the morning torn between a desire to improve the world and a desire to enjoy the world. This makes it hard to plan the day." At this conference, we need to figure out how to improve the world so that we will be able to continue to enjoy the world. The conference days ahead are a start. I look forward to a vibrant CE10 exchange of ideas where different perspectives can play off each other to chart a path to a livable future.
Thanks, Tom. It is now my pleasure to introduce Harry Atwater, Professor of Applied Physics and Material Science and the Chair of the Division of Engineering and Applied Science at Caltech, and one of the key organizers of the CE10 conference. Harry.
Okay, yeah, thanks, Neil, and welcome everybody to CE10. This is a very opportune moment for us to gather here together. First, I wanted to say a couple of words about the name of the conference, CE10. In 1960, President Kennedy then challenged the United States and the world to make a journey to the moon and bring astronauts safely return to Earth before the decade is out. And indeed, CE10, the 10 in CE10 evokes the idea that before the decade is out, we want to finish this journey of decarbonization by 50%. So we'll say in a moment a little bit about what the reference point is. The conference goals are to understand how to develop a pathway to 50% reduction in global warming gases from 2005 levels before the decade is out, before 2030. So what that requires then is to address the challenge of, within the United States, reducing further the carbon emissions of global warming gases by an additional 3.9 gigatons. And the approach taken in this conference is to think about the energy flows between their primary generation sources and end use energy services. And these are described in terms of the so-called famous Sankey diagrams that I'll show an example of in a minute, connecting these together. So essentially that's a wiring diagram for the energy economy. And the formidable task before us here in this conference is to figure out how to rewire the Sankey diagram describing US energy flows to achieve those decarbonization goals. So we can look at this data from the Rhodium Group and Breakthrough Energy Ventures organization called Climate Deck that plots the net US greenhouse gas emissions relative to international commitments. And you can see that greenhouse gas emissions rose from 1990 and peaked in the United States in 2005. And you can see also that the light blue line indicates the path that was outlined by the Copenhagen Accords and the Paris COP21 climate agreement targets. And from this, you might conclude that we are on track to meet the commitments to abate greenhouse gases. But what you can see here is that in this period where we have seen diminishing carbon dioxide emissions, the pace of progress is not as fast as is needed. Furthermore, we have been in a situation during the last decade where several events have conspired to limit the growth of greenhouse gas emissions and to limit the contribution of greenhouse gas emissions to global warming. Through the historic recession in 2008, whose effects on the economy persisted for a number of years. And then, of course, more recently during the pandemic, which also saw a dip in greenhouse gas emissions. So it's unlikely that at least so we hope that we will not see adverse events that limit the economic growth in the future as sources of greenhouse gas emissions. So we have to find other sources to achieve those goals. So another challenge that becomes apparent is that effectively we have a supply stack, if you like, of different sectors where carbon abatement can be achieved. Some of those have negative costs in the sense that if we simply are more economical in the use of energy services, if we are simply saving energy or recording energy efficiency, that can be achieved and also be something that's profitable in the same time. So there are probably a couple of gigatons that are of opportunity there in terms of carbon abatement before we reach the point where there is no net cost or no net gain to further carbon abatement. And then there is a number of segments of the energy economy where the cost of carbon dioxide abatement is perhaps below $100 a ton. And $100 a ton is an interesting target because that lies within the range of many of the widely agreed upon targets where carbon abatement could play a role as a tipping point. But we also see that relative to the 46 or 48 gigatons of CO2, which are being emitted worldwide, that almost half of them are coming from sources that are going to be very, very difficult, difficulty measured by cost, to abate. This data from Goldman Sachs shows that there are sectors, and we're very familiar with some of them. For example, global aviation across the oceans. It's going to be very difficult to curb our use of hydrocarbon fuels there. The cost of replacing fossil fuels with other sources of net zero carbon fuels is going to be very costly. That's just one example. And there are many other examples where the cost of abatement rises steeply. So the further we go down this pathway of decarbonization, the more difficult the challenge becomes. And so that is something that we have to take into account in developing our plans for progress. So really the data that I showed just a moment ago showed that between 2005, when we had a peak of carbon emissions, and 2019, there was about a 14% reduction in greenhouse gas emissions in the United States. So that constitutes about 1% a year progress in greenhouse gas reductions. However, to achieve the 3.9 gigaton reduction that is going to be required by 2030, we need 4 to 5% per year reduction in greenhouse gas emissions, or in other words, 4 to 5 times the present rate of reduction. So that illustrates the challenge. If we look at the supply stack, the slope gets steep as we go to further and further into the sectors of the economy that become increasingly difficult to decarbonize. And we need to accelerate the pace of progress to stay on track to meet the climate goals, 50% reduction between 2005 and 2030. So it's not as though we are completely devoid of ideas in this area. During the period prior to 2020, between 2016 and 2020, the federal government chose not to develop a national agenda for climate change. The leaders in this area, one of, for example, former Governor Jerry Brown, who we'll be hearing from later today, together with Michael Bloomberg, developed a pledge, America's Pledge, to advance and note the progress that's possible, even in the present, even during that time, in the absence of federal action. And America's Pledge, for example, led an effort to collect data on non-national climate action to quantify and report the progress made towards the overall US pledge for greenhouse gas emissions, and communicated those findings to the states of the United States, the cities and counties of the United States, as well as the international community and the United Nations. And that had the effect of catalyzing climate action in the near term by providing detailed roadmaps, and it fostered a sense of engagement at the community, municipality, community, county, and state action in the United States, and basically showed that the rest of the world that progress is possible, not only on a nation state basis, but on at the level of smaller governmental jurisdictions. So as we go forward, what's going to be required is an all-in approach. And America's Pledge gave a first outline of one such approach, an all-in approach that is effectively is an all-of-society strategy for action to deliver the greenhouse gas emissions that are required to achieve the 50% below 2005 levels in 2030. And what America's Pledge concluded was that the electricity and transportation sectors, which are could be the biggest contributors to overall emissions reductions by 2030, represent effectively 80% of all the reductions opportunity. During the 2016 to 2020 timeframe, this progress was made in communicating the opportunities and goals at the subnational level. And then, of course, since 2020, we've had an aggressive set of proposals and policies proposed and put forward by the current administration for a national climate agenda. So in order to achieve the 50% global warming gas reduction via an all-in strategy, there are a number of components. We need to address all of the sectors that include electricity generation, the residential sector, the commercial sector, commercial buildings, particularly the industrial sector and transportation sector. Another thing we need to do is to assess the percentage probability of success in reaching the targets in each of these areas. For example, we could have a big opportunity in one area, but perhaps there is great resistance or great difficulty in decarbonization. So we want to find not only the size of the opportunity, but the probability of success in every area to assess the pragmatic path forward for greenhouse gas reductions. Then we also want to determine the investment that's required, investment being the tool or the fuel that will enable that progress to be made. And then we also want to define the required local, state, and federal regulations and incentives. This is a pace of progress that's much faster than the pace of progress that we're used to at universities like Caltech and Stanford, where the innovation cycle begins with basic research, the development of innovative ideas that are patented and then are translated into the private sector and lead to formation of new companies or investments in companies that take perhaps a decade or more after that stage, often longer than that, as long as 20 or 30 years before technologies come to mature fruition. We're talking about now making progress on a timescale in less than a decade to achieve this final goal. So we require effort and thinking about the opportunities that lie in these sectors without the normal innovation cycle pace of progress. And that will also require then collaboration among many, many sectors. So, for example, this Sankey diagram, very nice set of comprehensive Sankey diagrams, is published annually for the United States and different states within the United States, describing the connection between primary energy generation sources on the left and end-use energy services in each of these sectors: residential, commercial, industrial, and transportation in the United States. There are also Sankey diagrams for carbon footprint or carbon emissions. And what they illustrate is the size of the opportunity to enable decarbonization. We can see here, for example, we have carbon-based sources of energy in coal, natural gas, and petroleum. And we can see how they are connected to various end-use energy services. For example, petroleum primarily wires to transportation and industrial, whereas coal is used primarily for electricity generation. Natural gas is used for electricity generation, but also direct heating in industrial process and residential and commercial home and business heating applications. And we can see also where renewable electricity and where renewable energy sources are contributing at the moment, primarily in electricity generation. And starting with this kind of map, we can then determine what are the opportunities for rewiring the Sankey diagram to achieve a state of configuration between primary energy generation sources and end-use energy services in 2030 that can enable this 50% decarbonization relative to 2005 levels. So what we have 8 years that remaining, less than a decade. So the theme of this conference is going to be to assess the questions of how these goals can be achieved. We've seen amazing progress. For example, just this month, the world achieved its first terawatt of installed solar electricity. And in early May of this year, California, as an example, was able to power on one day in early May, on May 8th, close to 100%, essentially fluctuating around 100% of its electricity generation on from renewable sources. So those are examples of progress and opportunity. But those are isolated examples that show the pace of progress, but they don't necessarily, without careful analysis of this connection between primary energy generation and end-use energy services, indicate how the goals can be achieved. And what we require are not only technical solutions of the kind that engineers can envision starting from the research level, but we need solutions that are available at acceptable costs. We need solutions that are politically and pragmatically possible. We live in a world where there are diverse political interests, and the pace of progress is not only indicated by the direction arrows of technical feasibility and cost, but also what's politically possible. And all of these factors together weigh in the final balance to achieve the historic reductions in greenhouse gas emissions before 2020. So up for discussion in CE10 are what are the possible pathways in an all-in scenario where we consider all of these sectors, transportation, commercial, industrial, residential, connecting to all of the primary energy generation opportunities. We want to discuss, for example, particularly with former Governor Brown and with the Representative Jared Blumenthal from Governor Newsom's administration, plans by California as a leading energy state. We want to assess how technologies like solar, wind, nuclear, hydro, geothermal, and biomass, which are green technologies for electricity generation, can be scaled and in a very short period of time. Of course, the most apparent opportunities are very often through efficiency improvements, so-called negawatts, that can be achieved simply by saving energy and saving cost at the same time. So what are the opportunities that remain there? And then finally, although CO2 is our most pervasive greenhouse gas in the atmosphere, it is not our most potent greenhouse gas. We have other greenhouse gases like methane that pose a much greater impact in terms of global warming potential than does CO2. So for example, could we achieve even more rapid reduction in greenhouse gas emissions and their global warming potential by going after potent greenhouse gases like chlorofluorocarbons and methane, in addition to CO2 as first targets, for example, by tightening the delivery systems in the natural gas network. So those are some of the many different points of discussion that will be brought forward in the conference. And we have a diverse array of speakers that are going to address the conference themes. And we're going to be hearing from people from many, many sectors of the economy and have the opportunity to generate a dialogue among many of the key actors through this conference. So we welcome your interest, your questions, your participation through your questions, and look forward to moving forward to address these kinds of questions to achieve these historic reductions in greenhouse gas emissions. So I'll look forward to the subsequent presentations for today, Neil.
Thank you, Harry. Before you pop your head off of the screen, There were a few questions that I think we have time to take that sort of address the general overview presentation that you gave. One is, to what extent do we already have ready all the applicable technologies to achieve the reduction target? When do we start really needing to look for future technologies versus the ones that are available now?
Well, so the question of whether we have all the technologies in hand, I would claim is not the only question we have to address. We have to address the question, do we have the technologies, and then can they be feasibly scaled at the pace that's required to achieve progress? And that's a key question that we need to address. For example, I brought up the fact that on a particular day in early May, California was generating 100% of its electricity, meeting 100% of its electricity demand through renewable sources. So the question is, why can't we achieve that progress every day of the year in 2022 rather than one particular day in May? And that has to do with the balance among all renewable sources together with demand, which is mediated by available energy storage. And we have other times of the year and other times of the day in a diurnal cycle when we don't have the energy storage to meet all of the electricity demand through renewable sources. So that's an example where we have apparently some of the technologies, but we don't have all of the technologies in a deployable form.
Great. And since we've got just 1 minute left, and you addressed it here, and your primary role is as a professor and administrative leader here at Caltech, what role does Caltech hope to play, given that the academic timeline is so different from the one that you laid out here?
Well, I think institutions like Stanford and Caltech need to use their convening power to bring together experts, domain experts, and thoughtful leaders across all of the sectors that need to contribute to solutions. The other thing I think we want to try to do is to bring the thinking of our academic colleagues to this timeline, this less than a decade timeline that they're not necessarily used to thinking about. That's the goal for the academics, but the goal for the larger community and for all of us is to foster an interdisciplinary forum where we can all meet together and consider all of the facets of this multidimensional challenge.
Great. Thank you so much, Harry, for setting the stage. And Harry will be popping his head in and out throughout the day to chat with some of the speakers as we go. And of course, he'll be also in conversation with Governor Brown later this afternoon.